Alright, we're on to solving equations with variables on both sides. Variables, remember, are our letters or our bombs. Remember, we want to try and get them to one side of the street first. So in this case, we could either subtract 9k, because 9k, take away 9k leaves us 0. That's what we want. Don't leave any bombs on one side of the street. You got to get 0. So if we look over here, negative 4k, to get back to 0, I would add it. I'm going to do that because I like things to be positive. So now I've got negative 4, positive 4k, I have 0. So I didn't leave any bombs on that side. And now I have 13k minus 44. Okay, and now k is all by itself. We need to save our 44 and save our 13. So we get our 0 by adding 44. And bring down 13k. 4 and 8 make 12, carry the 1, so it's 52. And now we got to get rid of the 13, save the 13. It's multiplying, number next to letters multiply. 13 over 13 is 1, and k equals 4. If you were to plug this into the calculator to check it, you would have to do negative 4, parentheses 4, plus 8, hit enter. I'm going to do this in my head, so I got negative 16 plus 8, that's negative 8. So I got negative 8 on this side. Then over here, I'd have to plug it in again. So 9 times 4 minus 44. Well, 9 times 4 is 36. 36 minus 44. Let's see. Yep, that is negative 8. So we're getting the same number on both sides. That means we got the correct answer. K is 4. All right. Again, we need to get our bombs on the same side. That's these R's right here. So I have two choices. I'm down 2 here, and I'm down 5 over here. So in this case, I could add 5 to get to 0, 5R, or I could add 2R to get to 0. It doesn't matter. Let's do add 2R. I do know that I'm going to be left with negative, but that's okay. So negative 2R plus 2R is 0. I didn't leave any bombs over there. That's good. Don't leave any on that side of the street. So now they're all on one side. I got negative 5 plus 2. So that's negative 3R. Bring down negative 18. And then again, R's all by, or the bomb is on one side. We need to save the 18 and save the 3. So the first thing we do is we save the 18 because that's going to get us 0. Bring down negative 3R. 12 and 18 make 30. And the last step, divide negative 3 both sides, because negative 3 over negative 3, we should say a number next to a letter here. These are timesing, just so you know, right here. So we would want to divide it out. So negative 3 over negative 3 is 1. And R is 30 divided negative 3 is negative 10. And again, if we wanted to check it, we'd have to check it both sides. So we'd have to plug it in to the left, see what it's equal to, plug it into the right, and make sure they're the same. All right, here it looks slightly different. So what we need to do is we need to distribute first. So negative 2 times 3, negative 3 is positive 6p. Negative 2 times positive 1 is negative 2. Well, this problem is slightly different than ones that we just did because, let's see, if I want to get my bombs on the same side, I got 6p here, so I'd have to take it away. I got 6p here, I'd have to take it away. So I'm going to minus 6p both sides. I got 0 here, I got 0 here. I don't have any bombs left. So, but I do have an 8 here, and I do have a negative 2 here. Is 8 equal to negative 2? No, it is not. These are not equal. This symbol means not equal. So in this case, since they're not equal, the answer to this, there's no answer. There's no solution. There's no number that you can plug in for P and make it equal on both sides. There's no number that will make that equal on both sides. That is why there's no solution. Okay, so this one, let's group together our like terms here. So we got negative 2w. I got 12 and 20, that makes 32. Over here, 9w minus 1. Again, we got two choices. We could minus 9w to get 0 bombs on the left, or we could add 2w to get 0 bombs on the right. So it really doesn't matter. Let's add 2w because that's what I felt like doing. You're down to w. We add 2w. We're going to get 0. That's good. We didn't leave any bombs over there. 9 and 2 make 11w. Bring down negative 1. Again, we need to save the 11, save the 1. We save the 1 first because that's going to get us 0. Bring down 11w. 32 and 1 make 33. And to finish it out, we divide the 11. Number next to letter is timesing. We divide 11 over 11 is 1. W is 33 divided 11 is 3. Alright, this is similar to one we've done, so we're going to distribute. Anytime you see distributing, that's a good place to start. So negative 3 times 8 is negative 24. Negative 3 times this little hidden 1 right here. So I'm going to times negative 3 and negative 1. That gives me positive 3n, because a negative 3 times a negative 1 is positive 3. Okay, bring down on this side what I've got left. And now I just need to solve this problem like I did the others. So I got bombs on both sides, need them together. So I can move my 3. Since I have 3, I'd have to minus 3n, or on the right, I could subtract the 4n to get 0. So I'm going to minus 3n. Again, it doesn't matter which way you go. So 3n minus 3n is 0. That's a good thing. No more bombs, so negative 24 equals 4 minus 3 is 1n. Well, I know 1n is the same as n, so I'm just going to write n. Minus 17. And now, in this case, all we need to do is save the 17, and that would be by adding it. If you're down 17, got to add it to get 0. And now, negative 24 and plus 17 is going to get us negative 7. So n is negative 7. Okay, this one, it looks slightly different. We still have bombs on both sides. In this one, because we've got some people here, let's move our bombs all to the right side over here, because that way, by doing that, that means that we'll leave all these smart people over here. So I'm going to change color. All these people right here, they're going to be all alone if we move the 7. So let's do that. Let's move the 7C. And I don't want to leave any bombs over there. That's why I'm minusing to get 0. And if I minus it on this side, well, now there's no more bombs with these people here. That's a good thing, right? You saved them. So we're going to bring down negative 10. And then this over here, we got 12 take away 7 is 5C. And the last step, we just got to save the 5. So number times a letter, or number next to a letter is timesing. So we're going to divide it out. 5 over 5 is 1. So C is negative 2. All right. This one, We kind of got a minefield over here, so we want to get our bombs all together in a neat little pile. So we're going to do -2, take 3. Okay, so we got 2 negatives, 1, 2, and we got 3 negatives. So that's a total of 5 negatives, and we need our e there, equaling 8e plus 13. Well, because all we have over here is just on the left side, that would be this side, all we have over there is bombs. But over here, on the right side, if we save our 13, let's move all our bombs to the left. That way the 13 will be all alone, and that's good. We want to save it. So we're going to minus 8e both sides to get 0 left on the right. So 13 is happy, and we've got -5, take 8 away, so we got -13e. And the last step, we just need to save the -13. Remember, number right next to letter, those are timesing, so please divide it out. I see a lot of people try and add. Don't do that. Number next to letters times divide. So -13 over -13 is 1. E is 13 divided -13 is -1. All right. So here again, we're going to distribute. So we got 2k plus 4 equaling, well, 2 times k is 2k. 2 times 2 is +4. Well, we got the exact same thing on both sides, but I'm going to do what I normally do. So I'm going to get all my bombs on one side. If I have 2 of them here, I have to take them away. So I have 2k minus 2k, 0. 2k minus 2k, 0. Bring down the 4, bring down the 4. Well, in this case, these are equal. And when they turn out to be equal and you don't have any more bombs left, that means that any number you plug in, any number works. Okay, so it doesn't matter what you pick for k. If you pick 100 and you plug it into both sides, it's going to equal. If I plug in 7 into both sides for k, it's going to equal. Any number you pick will work. That's what this means right here. That means there's so many choices that we call it infinite solutions, because there's so many solutions. It's infinite. So again, I could pick a half. I could put in a half on both sides for k, and it would equal. So that's what that means.